Well, hello scrappers, Mike here. Welcome back to my channel. So what's going on today? Well, today we're going to talk about Jerry's silver solder. Now, back a while back, a guy contacted me and said, "Hey, Mike, I work in an industry that uses a lot of silver solder. I've got a lot of solder ends, and what I would like to do is recover the solder from them. My employer lets me keep the solder ends." So he would like to find a way to recover the silver from this stuff here. And he specifically said he didn't really want to use nitric acid if there was a better way to do it. I told him, well, I'm kind of busy with Johnny's stuff, but I'll get to this when I get a chance. So I've had a little bit of time recently between Johnny projects. I'm doing some R&D in the background on his stuff. I'm not really filming it. So I've been working with this stuff a little bit. And, well, I was in for a couple surprises with this. And here's the thing. When I first got these, he sent me 2 kilos of his silver solder rod ends here. And I got a technical data sheet here saying what's in it. 56% silver, about 22% copper, about 16 to 17% zinc, and about 5% tin. Okay. And I thought that's what I was dealing with here. But then when I started taking a close-up look at these things, the rod ends really didn't make sense to me the way they looked. They didn't just look like the end of a piece of silver solder. Um, so that was the first thing that didn't look quite right to me. And then they're mildly magnetic, which also doesn't make sense for silver solder, because these components, there's nothing magnetic in them. There's no ferromagnetic material there. They should not be attracted to a magnet if they're silver solder. Okay, so I had to figure out what I was actually dealing with here. So I did some testing. I took 100 grams of these and I dissolved them in nitric acid. Exactly what Jerry said he really didn't want to do. Let me show you what I got from that. Okay? So here's what's left that didn't go into solution right here in this beaker. Here's this blue liquid back here. That's going to have silver, zinc, copper, and tin in it. It certainly has copper because you can see by the color, okay? This stuff didn't dissolve. So how much have we got left? Out of that 100 grams of material I put in nitric acid, we got 92 grams left. That tells me only 8 grams dissolved. And the rest of this stuff looks like some kind of stainless steel end for the rods. So we only got, 8% of material roughly in there is actually silver solder. The rest of it's these, I don't know, stainless steel ends. They're mildly magnetic, but I think they're some kind of stainless steel because the nitric acid didn't touch them. So, yeah, so we only got about, and I only did 100 grams. Only 100 grams. I mean, some of these look like they have big blobs of solder on the end of them, and some of them look like they are totally clean, like they have no solder left on them. So, it's kind of an average. Maybe on average, out of 100 grams, you'll get 8 grams of solder, okay? Now, since the solder is only 56% silver, since we dissolved 8 grams of metal out of that 100 grams of rod ends, let's see, what's 56% of 8? It's going to be a little more than half of it. Yeah, 4.48 grams. So out of 100 grams of these rod ends, I should have 4.48 grams of silver in solution in that beaker. So not a huge amount of silver here. Even in this 2 kilos of stuff here, going by this, we should have, what? 89.6 grams of silver, maybe, in this 2 kilos of stuff here, if I did the math right. So, yeah, not a whole lot of silver. So, since this is mostly steel, there's not that much I can do with it. I can't do any kind of pyrometallurgy with it because it's all steel, you know? Um, let's see. I can't run it through an electrolytic cell. I don't want to put iron and nickel in my electrolytic cell, because that's mostly what it is. Let's see. What else could I possibly do with it? I can't compel it, because again, it's mostly steel. You know, the steel's just going to oxidize and make a mess. In fact, I actually tried it. I'll insert, a photo of the resulting mess. So, yeah, all that steel is going to cause problems. And the fact that there's actually very little silver here, very little solder on the whole at all. It's mostly steel. So, what can we do? Well, I'm sad to say, Jerry, your best bet is probably dissolve it in nitric acid. Um, you get clean stainless steel out of it as a result, which I guess you could take to the scrapyard and make a little bit of money on. And then your silver's in solution, and you could drop it out of solution with some copper. So that's an idea. And of course, since there's so little actual silver here in this stuff, it's not going to take you an outrageous amount of nitric acid. I think you were possibly concerned about the cost of the nitric acid. Maybe I'm wrong. Maybe it was the fumes you were concerned about. But if it's the cost of nitric acid, nah, you don't have to worry too much about it. Like this 100 grams that I dissolved in there, okay, it takes, conventional wisdom says it takes a milliliter of acid to dissolve a gram of silver, all right? Now, we had copper, zinc, and tin in there, and I know copper takes a whole lot more acid than silver does to dissolve, about twice as much. Not sure about the zinc and the tin, but let's say it takes 3 times as much nitric acid to dissolve the silver solder left on these rod ends as the silver that you're going to get out of it, okay? Well, still, you're only looking at like 13, 14 milliliters? No. Yeah. You're still looking at only like 13, 14 milliliters per 100 grams of material. Or 130 milliliters for a kilo. It's going to take you a long time to go through even a liter of nitric acid, and you'll be able to strip a lot of these rod ends using nitric acid. So, sad to say, Jerry, the one method of doing this that you didn't want to do is probably the best way to go. I'm sorry to say. Just because I can't think of another way to do it, let alone an economical way to do it, that doesn't involve the nitric acid. Just because we're dealing with 92% steel here. And fortunately, it's stainless steel. It seems to be anyway. The nitric acid isn't touching it. This stuff comes out nice and shiny and clean and untouched. If it was a milder steel, we'd have problems with the acid attacking it, and we'd have a really, really dirty solution over here that we'd need to try and get our silver back out of. Whereas this is pretty darn clean. It's kind of milky white from the metastatic acid created by dissolving the tin, but I can filter that out. And then I can drop the silver out of it. Pretty darn easy. So yeah, I mean, I think, unfortunately, Jerry, and I tried, buddy, I really did. I think that's your best bet, right there. If you want to try and get the silver out of this stuff, that's your best bet. And it's not going to take a whole lot. Like I said, a liter bottle like this, you're going to be able to do like 10 kilos of this stuff with a liter bottle of this, with as little silver solder as there is left on those rod ends on average. So, yeah, I think it's the best way to go. Just soak these in nitric acid, dilute nitric acid until they're clean like these, and then filter the liquid, get the milky stuff out of it, and then put in a coil of a heavy-duty copper wire or a copper bus bar or something in there and cement out the silver. And you'll probably get 99+% pure silver out of it. It's not 3 nines fine, but if you wash it really good after, it cements out, you'll have some pretty fine silver. And it's going to be dead easy, and it's not going to cost you very much. So that's my best advice for you, Jerry. I can't think of any other way to do it, let alone, a way that's more economical than using the nitric acid. I just don't see it. And certainly this is going to be the easiest way, I think. In fact, Jerry, that's exactly what I went and did. I did most of it off camera, but I went ahead and dissolved the 2 kilos of rod ends you sent me in nitric acid. I've got a lot of liquid here, but that's because it took a lot of liquid to dissolve all that solder, not because it took a lot of nitric acid. It took about 300 milliliters to dissolve all the solder in those 2 kilos of rod ends. Well, a little under 2 kilos because I had done some experiments with some of those rod ends with my abortive attempt at coupelling and some other stuff. So we were a little short of 2 kilos, but basically it took about 300 milliliters to dissolve all that stuff. And I think, if anything, this stuff is probably way over nitrate. So let me drop the silver out of this, and we'll see how much we get. And I'll show you just how easy it is to do. And since it didn't take very much nitric acid, it's not going to cost you a lot of money if you go this route. So let's do this thing. Let's drop the silver out of this pretty blue liquid and see just how much of it there is in just short of 2 kilos of your silver solder. So any guesses? Anybody wants to post a guess in the comments of this video, go ahead and we'll see who comes closest. That should be interesting. I've got my own theory based on the difference in weight of the material before and after the nitric acid treatments and the fact that it's 56% silver. So we'll see what we actually get out of this. I'm going to try and capture a time-lapse video of the silver coming out, but I did say that this might be a little over nitric, so we might have a little bit of a delay before the silver starts coming out in earnest, because it's going to redissolve and then re-cement and redissolve, re-cement, redissolve, re-cement until all the nitric acid is used up. Alrighty, here we go. I got my GoPro taking a time lapse of it. Let's see what happens. That in there. Windy day. Let me put a rock on top to keep it from blowing off and debris from blowing in. It looks like, yeah, we've already got silver plating out on it. It doesn't look like copper anymore. Okay. Well, we'll just let this go for the rest of the day and see what the time lapse looks like. Maybe it's not as over nitric as I thought. Maybe we'll actually get some good video of the silver cementing out. Okay, I guess I was totally wrong about this taking a while to get started, because it's been like a minute, maybe. Of course, I see a lot of bubbling, so that tells me there is a lot of nitric acid in there. So yeah, this silver that's coming out, it's just going to redissolve, go back into solution, and come out again. And this is going to keep up. Yeah, we can start to see some brown orange fumes up in the top of the beaker. I don't know if they're showing up for you, but I see them. So yeah, this is going to keep up until that nitric acid is used up, and then the silver will come out of solution and stay out of solution. But what that tells me, Jerry, is it's not even going to take 300 milliliters per 2 kilos of your solder ends to get the silver off. Maybe 250, maybe even less. I don't know. On average, you know. But we got a lot of silver here. That's for sure. There's a lot of silver in there. Okay, so we're just going to let this go because I'm just amazed at how quickly this reaction took off. The liquid might even get warm. It's not yet, but we've got a pretty vigorous reaction in there, so I wouldn't be surprised if the liquid gets warm too. But look at the silver falling down to the bottom of the beaker there. That's amazing. We should be getting an interesting time lapse. It's actually happening too fast for the time lapse. And the liquid's pretty much gone opaque too with silver, so I don't know what we're getting on the time lapse. I guess we'll find out. Well, it's been about another 10 minutes. Can you see how that's boiling in there? It's actually gotten quite warm, but not hot enough to boil. It's just the nitric acid reacting with the copper coil I put in there and reacting with the silver that has come out of solution. Notice the silver is not really accumulating very much on the bottom. It's going right back into solution. So we'll see how long it takes to use up all that nitric acid in there. Hopefully it doesn't use up all the copper before it uses up all the nitric acid. I kind of doubt there's that much acid in there. So we'll just have to let it go and see what happens. All right, the reaction was getting so vigorous and the liquid was getting so hot, I decided that this was a little bit crazy out of control, so I denoxed the liquid with some sulfamic acid, dissolved it in water, dumped it in. There was a lot of foaming, but look what the difference is. The liquid has cleared up. It's not like it's boiling anymore. There's a little bit of gentle bubbling still. Some of that might be from residual sulfamic acid on the bottom of the beaker, but we've got a much more sedate reaction now, and we'll see how that goes. I think we'll get some good crystal growth now, and get all of that silver out of solution with a lot less drama and a lot less orange fumes, which were really just boiling out of there like crazy. So, okay, I got the time lapse going again. I stopped it because there was really nothing for it to see. The beaker had gone opaque. But we'll see what we get now. It looks like we've got some nice, super shiny silver crystals growing in there. I don't know if the shininess of those crystals is coming through on the video, but as I move my head around, there's a lot of sparkles in there. Those coils are really getting covered. It should start accumulating now, I think. I should have denoxed it up front. I did what I should have done up front is denox it. So I think we're good to go now. It's just a matter of waiting and see what we get. Alrighty, it is the next day. So this has been almost 24 hours since I started this. I shook all of the silver off of the coils this morning, and it's all settled down here into a nice layer on the bottom, and really nothing more has formed on the coils. Now, normally I would give this a couple of days for the process to run to completion, but I think this liquid got so hot initially because it wasn't denoxed and the reaction was so vigorous. I think that the hot liquid caused the process to run to completion pretty quickly. But we're going to test it and make sure we don't still have any silver in solution. So I've got some tap water here with a little splash of hydrochloric acid in it. You see the liquid's kind of clearing from the top down. I'm going to get some of this clear stuff up here. Put it in there. Yeah, not really seeing much. A little more maybe. Now, other than turning the liquid a little bit blue, it's basically crystal clear. So apparently there's no silver left in solution. So all the silver that we're going to get out of this stuff, we've already got out of it. So that's good news. So now what I need to do is get that coil out of there. Oh yeah, it's coming out nice and clean too. And look at the shine on that coil. That's like, it's a lot thinner than it was, but it is just so shiny, such copper shine, such a copper shine to it. That's nice. Yeah, it's definitely a lot thinner than it was. That was much heavier gauge wire when it went in. Okay, so what I'm going to do is I'm going to set up to filter this liquid off, and we'll capture whatever amount of silver's in here on the filter, and we will wash it really, really well. Then we'll dry it out and weigh it and see how much we got. All right, let's get this stuff filtered. I got just shy of 3.5 liters of liquid here, so I'm going to have to empty my receiving flask once or twice to get all this in. That's okay. So what I want to do is get all the liquid over first, and then dump the solid silver into the filter. Let the vacuum pull the liquid out of it at the same time as I'm putting distilled water through it to rinse it and get as much of the blue stuff out of the liquid as I can. Because that blue stuff is contaminated with copper, tin, and zinc, and maybe other stuff too. So we want to clean that up. But first, I got to get all this liquid through. I want to do that before I pour the silver in, because all that silver powder will plug up my filter, and the rest of the filtration can take forever. So anyway, we'll be back when I've got all the liquid through and the silver in the filter, and I'll show you the rinsing process. All right, got all the liquid through. Let's get all this silver into the beaker here and start rinsing the blue stuff out of it. Yeah, there we go. Gonna rinse it out with a lot of distilled water. Till the liquid runs out of the funnel here clear. Come on, everybody out. There we go. All right. And I'll give you a look at it once I clean it up a little bit. It's purty. There's a fair amount of it too. Let me get it cleaned up a little more and I'll give you a look. Alright, so as to rinsing, how much do you rinse it? Well, I rinse it until the liquid stops coming through blue, like it is now, and then I rinse it just a little bit more to be certain. So I'm going to put a little bit more. In my case, I'm using distilled water. I'm not sure distilled water is really necessary for this final rinse. You could probably get by with tap water. Our tap water here is really hard, so I'm using distilled water just not to add a lot of calcium and magnesium to the now clean silver. But you might be able to get by with tap water in most places, or well water. It might be good enough. And sorry, there's some fighter jets flying over right now. For some reason, they've been flying over our house a lot lately. So I hope you can hear me over them. But anyway, that's probably the final rinse. I'll give you a close-up look at the silver in the funnel there. Well, there it is, Jerry. There's the silver. I hope all the little sparkles on it show up. They're very obvious to the eye, but they're not coming through so good on the camera. All those little sparkly silver crystals there. Now they're nice and clean. So once the pump's done pulling the liquid off of them and they're as dry as I can make them with the pump, I'm going to pull the filter out and we'll dry it out over low heat. And then we can weigh this stuff and see how much silver we've got here. Remember, you're supposed to be putting your guess down in the video comments, and no fair waiting until after I weigh it. Put your guess in now. Okay, there's the silver. Got it on the hot plate over low heat. Gonna dry it out so we can get a weight on it. That is some pretty silver. That is really shiny. Pretty darn clean too. I'm sure it's not 3/9 fine, but probably 995, 996, 997 maybe. It's really good looking silver. Only electrolytic cell could get it any better than this, but you may want to stay tuned in the future. We may play around with one. So yeah, subscribe to see that. I'm coming up with a different design than one you've probably seen before. So anyway, we'll let this dry out and then we'll weigh it. All right, it's the moment of truth. This silver is nice and dry. Let's find out exactly how much we've got here. I don't know if you can see that. I'll zoom in on it. That is some beautiful silver, though. You know what? I'll tell you what we'll do. There's a lot of it stuck to the filter, so I'm going to stick the filter in there. All right, so we're exactly 99 grams with the filter. All right, let me get another filter, and we'll measure it and subtract that from 99. What do we got here? We got 4 grams. So we subtract 4 from 99. That's 95. So we got 95 grams of silver over here. So that's a little better than I was expecting. My guess would have been 84, around 84 grams. What was your guess? I'll look around in the comments and see what people guessed. But we actually did pretty good here with that silver solder from Jerry. Better than I expected. And Jerry, this was easy. Don't let the nitric acid intimidate you. It was easy. This really only took a few hundred milliliters of nitric acid. All you got to do is put the stuff in a glass vessel. You don't even need fancy labware like I'm using. You can get by with whatever. You know, cover it with distilled water so it's all submerged, and just start adding acid in small increments until you get all of that solder dissolved and you're just left with the clean stainless steel ends in there. Filter the liquid. Put some copper in it. Maybe denox it with some sulfamic acid. You know, if it's overnoxed, like mine was, put some copper in it. The silver will cement out. Wash it really good, and you're left with some really, really pretty silver here, ready to be melted down into bars or buttons. Okay. Like I said, not 3/9 fine. Although this looks like the absolute best and cleanest cement silver I have ever produced personally. So probably close to 3/9 fine, but not quite there. And that's it. That's all there is to it, Jerry. So sorry I couldn't come up with a method that didn't require nitric acid that I thought would work, but this really, don't be intimidated by it. It's easy. You can do it too. And you can start recovering the silver from your big stockpile of rod ends. Okay, well, I hope you found this helpful, Jerry, and I hope everybody else watching found this video interesting, educational, informative, helpful, useful, whatever. If so, give it a like, give it a thumbs up. I'll see you all in the next video. Thanks for watching this one. Bye.